Section 7.3, Binomial and Radical Expressions. When we add or subtract terms, they must be like terms. That is no different with radicals. So like terms with radicals are radical expressions that have the same index and the same radicand. To perform this operation, we need to simplify all radicals in the expression first to determine if there are like terms. If so, then we can combine them. We do not change the expression or the number in the radicand or the index when adding or subtracting radicals. Let's take a look at a couple examples. Here I have a -2, square roots of 3. We know what a double negative is going to give us a plus sign, 5 square roots of 3. Our index on both is 2. Our radicand is both 3. Therefore, I treat this like a 2x and a 5x. So I just add or subtract their coefficients. Here, a -2 plus 5 is 3 square roots of 3. I do not change my radicand or my index. On this example, I have the cube root of 5 plus 6 square roots of 5. Therefore, on this, I cannot simplify. This is not possible to go any farther. And that is because even though our radicands are the same, our index is different. Here it's 3, here it's 2. Therefore, it's not possible to simplify any further because these are not like terms, while in this situation, these were like terms and I could simplify. Here, I have another expression. I notice on this situation that I have the index for each radical that is the same, but my radicands are not the same. Again, I'm not able to simplify. And that is because these are not like terms. On this problem, I take a look at my radicals. They are the square root and the square root, so my indexes are both 2, and my radicands are both y. They are the same. Therefore, I'm going to treat this just as they were like variables. I'm going to add or subtract the coefficients and keep my radical the same. 9 minus 12 is a -3 square roots of y. On this example, it looks like I don't have any like terms. Notice all my radicands are different, even though my indexes are the same. But what I need to do first to verify that is to simplify each radical and then determine if I have like terms or not. So here I'm going to have 2 square roots of 4 times 3 minus the square root of 16 times 3 plus 3 square roots of 9 times 3. The square root of 4 we know is 2. 2 times 2 is 4 square roots of 3 minus the square root of 16 is 4. What's left is the square root of 3. And finally, I bring down my plus sign. The square root of 9 is 3. 3 times 3 is 9 square roots of 3. When I go back and review the terms, I notice they are still an index of 2, and my radicands are all the same. Therefore, I have like terms. Now I just combine the coefficients. 4 minus 4 is 0. 0 plus 9 is 9 square roots of 3. In this example, I'm going to follow the same procedures before. Simplify each radical. Bring down my 6. Square root of 4 times 3 minus square root of 16 times 3 plus 7 square roots of 9 times 3. The square root of 4 is 2. 2 times 6 is 12. Square roots of 3 minus the square root of 16 is 4. Square roots of 3 plus the square root of 9 is 3. 3 times 7 is 21 square roots of 3. That generates like terms for each term, index of 2 each and a radicand of 3. Now I just combine the coefficients. 12 minus 4 is 8. 8 plus 21 is 29 square roots of 3. Again, I want to simplify the expression. I'm going to simplify the radicals to determine if I have like terms. Let's bring down my 8. I'm going to break up 72 into 36 times 2. Bring down my minus sign. 3. I'm going to break up the 8 into 4 times 2. Bring down the plus sign. 7. And I'm going to break 98 up into 49 times 2. Square root of 36 is 6. 6 times 8 is going to give me 48. Square roots of 2. Square root of 4 is 2. 2 times 3 is 6. Square roots of 2. And the square root of 49 is 7 times 7, which is 49 square roots of 2. Now I just combine like terms. 48 minus 6 is 42. And 42 plus 49 is going to give me 91 square roots of 2. On the next page, I have a product of two binomials. And from previous sections, we've been performing this operation, which is the FOIL method, or we distribute each term twice through the other binomial. And that's what we're going to do with these radicals. To make sure we do this correctly, we have to make sure that our radicands and our indexes are the same so that we can multiply inside our radicals. So let's perform the FOIL method. First, 2 times 3 is 6. Outer is a negative 4 square roots of 7. Inner is a positive 9 square roots of 7. And then my last terms, which is going to be a negative 6 square roots of 49. Now I want to combine like terms. I have my 6. A negative 4 plus 9 is going to give me 5 square roots of 7. And then I need to simplify this. Minus the square root of 49 is 7. 7 times 6 is going to give me 42. And I can simplify again. A negative 42 plus 6 is going to be a negative 36 plus 5 square roots of 7. Very similar to our last example, I have a binomial that is squared, so I can break that up into a product of its binomial. So I'm going to have the square root of 2 plus 2 square roots of 6. And again, square root of 2 plus 2 square roots of 6. Now I can FOIL. The square root of 2 times the square root of 2 is the square root of 4. We could simplify right away, but I'm just going to wait to the next step. My outer is going to be a positive 2 square roots of 12. My inner is going to be a positive 2 square roots of 12. And my last is going to be a positive 4 square roots of 36. I can combine like terms. The square root of 4 is going to give me 2, plus this is going to give me 4 square roots of 12, plus the square root of 36 is 6 times 4 is going to give me 24. Combine like terms is going to give me 26 plus, but I need to break up this radical, the square root of 4 times 3. And finally, 26 plus the square root of 4 is 2. 2 times 4 is 8. Square roots of 3. Again, on our next example, we want to use the FOIL method. So my first term when I multiply is going to be 2 square roots of x squared my outer term, a negative 2 square roots of 5x. My inner term is going to be a positive 2 square roots of 5x. And my last term is going to be a minus 2 square roots of 25. And I could have simplified in the process, but I wanted to show that next step. So here I'm going to have the square root of x squared, which I know is just x, so that gives me 2x. These two terms are like terms. Notice my index on the radical is the same, and my radicand is the same. Since they're like terms, I can combine. Here, a negative and a positive, they will cancel out. My last term is going to be a negative, and the square root of 25 is 5, and 5 times 2 is 10. Therefore, 2x minus 10. Again, I want to FOIL to solve this problem. My first term, when I multiply, 3 times 1 is 3. Square roots of y squared. My outer term is a positive 5. Square roots of 2y. My inner term is going to be 2 times 3 is 6. Square roots of 2y. And my last term, 2 times 5 is 10. Square roots of 4. I could have simplified, but I wanted you to see the process. This, when I simplify, the square root of y squared is y. Therefore, that's going to be 3y. The two middle terms are like terms. My index on each is 2, and my radicands are the same. Therefore, I can combine the coefficients here. A positive 5 and a positive 6 is going to give me a positive 11 square roots of 2y. And my last term, the square root of 4 is 2. 2 times 10 is 20. And my solution, 3y plus 11 square roots of 2y plus 20.